A warm welcome to everyone. Myself, I am Nandhini, working as assistant professor in mathematics at Trinity College for Women, Namakkal. Today we see what is fuzzy set and its operations with examples. Let's see what is fuzzy sets. Fuzzy set theory is an extension of classical set theory. Elements having varied degree of membership, a logic based on two truth values, that is true and false. Fuzzy logic uses the whole interval between 0 and 1 to describe human reasoning. Fuzzy set is any set that allows its members to have different degree of membership called membership function, that is having interval closed interval of 0, 1. Fuzzy logic is derived from fuzzy set theory. Many degree of membership between 0 and 1 are allowed. The membership function mu a of x is associated with the fuzzy set CA such that this function maps every element of universe of discourse x to the interval 0, 1. Mu a of x is x such that x tends to 0, 1. Fuzzy logic is capable of handling inherently imprecise concepts. Fuzzy set is defined as if x is an universal of discourse and small x is a particular element of x, then fuzzy set A is defined on x can be written as ordered pairs, that is capital A is equal to x comma mu a of x, where x belongs to capital X. Fuzzy sets example, let capital X is defined as z1 comma z2 z3 and z4 and z5 be the references of set of students. When we let us take fuzzy set A as smart students, a fuzzy set A is equal to z1 comma 0.4, z2 comma 0.5, z3 comma 1, z4 comma 0.9 and z5 comma 0.8. That A sets indicates that smartness of g1 is 0.4 and so on. The membership functions fully defines the fuzzy set. The membership functions provides the measure of the degree of similarity of an element to a fuzzy set. Membership functions can either be chosen by the user arbitrarily based on the user experience. That membership function chooses by two users could be different depending upon their experiences and perspectives, or be designed using machine learning methods, that is example artificial neural networks and genetic algorithms and etc. For these sets, that is different shapes of membership functions are triangular, trapezoidal, Gaussian, etc. Let's see, triangular membership function is specified by three parameters a, b, c, where a, b, c represents the x coordinates of three vertices of mu a of x in a fuzzy set A, where A is a low, small a is a lower boundary, C is an upper boundary, and B be the center of the membership function. That mu A of x is defined here, and it has a diagrammatic representation. And then trapezoidal membership function is specified by four parameters A, B, C, D as follows, and its membership function is defined here. Gaussian methods of membership function, mu a of x comma c comma s comma m is equal to exponential of minus 1 by 2 into x minus c by s whole power m. That whereas c is center, s is width and m is a falsification factor. Example, m is equal to 2. This diagram represents for the values of c is equal to 5, s is equal to 2 and m equal to 2. And two more examples also here for various c, s and m values. And finally, we have seeing fuzzy set operation, given x to be the inverse of discourse and a and b to be the fuzzy sets with mu of x and mu b of x or their respective membership function. The fuzzy set operations are as follows: union, intersection, complement, where mu a union of x is equal to maximum of mu a of x, comma mu b of x, that is that membership we have to compare the maximum values of membership functions in that set. Similarly, intersection means we have a union b in mu of a intersection b of x is equal to minimum of mu a of x comma mu b of x. And finally, complement is mu a of x is equal to 1 minus mu a of x. The examples for for fuzzy set operations, consider a equal to x1 comma 0.5, x2 comma 0.7, x3 comma 0 and b as x1 comma 0.8, x2 as 0.2 and x3 comma 1. Where we have the applying the union of function, we have a union b is equal to x comma 1, x1 comma 0.8, x2 comma 0.7, and x3 comma 1. Because the mu of a union b of x1 is equal to maximum of mu a of x1 comma mu b of x1. We have a mu of x1 as 0.5 and mu b of x1 as 0.5. Comparatively, 0.8 is the maximum value. So we have x1 comma 0.8 in a union b. Likewise, a union b of x2 we are having 0.7, and a union b of x3 is equal to 1. And then intersection, we are considering the same a and b sets here also. And a intersection b, we have x1 comma 0.5, x2 comma 0.5, and x3 comma 0. Whereas we have to compare the minimum membership functions of x1. Comparingly, 0.5 comma 0.8, we have 0.5 as the minimum value. Likewise, x2 we have 0.2, x3 we have 0. Finally, we have complement, that is considering a set here, x1 comma 0.5, x2 comma 0.7, and x3 comma 0. A complement is nothing but we have to subtract the membership function from 1. 1 minus 0.5 we have 0.5, 1 minus 0.7 we have 0.3, and 1 minus 0 we have 1. These are all about the fuzzy sets. This is a small introduction. Thank you.